Good evening, ladies and gentlemen. What I will be discussing tonight will be the concept of operation of a tie-grid inverter. This is a tie-grid inverter. This tie-grid inverter, the output of this one is plugged in immediately to our outlet. This is the output terminal of the tie-grid inverter. And the input terminals of the tie-grid inverter is this one here. So this is minus, this is plus. The lines going in here are actually the accumulated lines from all the solar panels that you are using. So the current entering here will be a direct current, and the output will now be an alternating current. The difference of this tie-grid inverter in comparison with the off-grid inverter. For the off-grid inverter, okay, we needed a battery here to be inputted on this terminal. Okay, and if you try to bring out or plug in your equipment over here, the output will now be an alternating current. So that's an off-grid inverter. Off-grid meaning it needs a battery at the input. For the tie-grid inverter, it doesn't need anymore a battery. To power up this tie-grid inverter, you just connect your lines coming from the solar panels to this input terminal here. This should be the minus, this is plus. So for a big load or for many solar panels, the current entering here will be a very big one. It's a direct current, and it will try to operate or go inside this inverter, and by using the conversion process inverter, meaning if you try to input DC, it will output AC. But for this tie-grid inverter to work, you must have to plug in its terminal to our outlet. So this is plugged into our outlet. Okay, this is the output terminal. Okay, so for as long as there is a DC voltage coming from the solar panels, this tie-grid inverter will be converting direct current to alternating current directly to its output. So big companies like Sam's Club are using this one. They got maybe a very big inverter, but they don't usually use so many batteries to power up the inverter. They just use the tie-grid inverter because for them, the current entering here should be in the 1000 amperes. So if the current entering will be in the 1000 amperes, of course, the output will also be in the 1000 amperes. So actually, they could power up all the air conditioners, all their lightings inside Sam's Club. Right? I will repeat it. This tie-grid inverter don't need any battery for it to operate. For as long as the current coming from the solar panels is injected here, okay, it will try to operate this one, and the output is now plugged into our outlet. Okay, this one. This is just a portable tie-grid inverter. So for this tie-grid inverter to work, the output should be plugged in to the outlet. The inverter should sense that there is a voltage at the outlet. Without any voltage, the inverter will not operate. Okay, so the requirement for this tie-grid inverter to work is that when we plug in its output, this inverter should know that there is a voltage on the outlet. Without the voltage on the outlet, it will not work. Even though you inject a DC voltage here, if this is not plugged in, you could not get an alternating current here. For an alternating current to be coming out here, they should be plugged in to the outlet. That's why our outlet, our houses, is connected to the grid, right? That's why the name of this one is tie-grid inverter. Okay, I will repeat it. This tie-grid inverter doesn't need any battery for it to operate. The voltage coming from the solar panels will be injected here. No more battery. No more battery. This will operate. The output of this one will be alternating current. This is the output terminal, and the output terminal should be connected to our outlet. And once it is connected to our outlet, of course, current will now be coming out from here, and we could use it now in our houses. Okay, so if you are still getting current on the utility line, and you try to plug into this one to your outlet, this one will help minimize your electricity, because this one is contributing already alternating current to your house lines, meaning to your house circuits. Okay, the good thing about it, this tie-grid inverter doesn't need any battery. Whatever voltage coming from the solar panels, it will be injected here. This will operate. The output now will be alternating current, and the output terminal should be plugged in to our outlet for it to deliver current to our house wirings. Okay, that's the difference of a hybrid inverter from the off-grid inverter. For the off-grid inverter, it's a stand-alone connection, because when you use a alternating current, that inverter will be operating by using the battery, which is connected at its input, but that battery is being charged by the solar panel. And here, for the tie-grid inverter, it doesn't need any more battery. So actually, it is much economical to use a tie-grid inverter than a what you call this off-grid inverter, because a tie-grid inverter doesn't need any more battery. You just input your terminals here coming from the solar panels, no more battery. Okay, this inverter will convert direct current to alternating current, and the output is actually plugged in to the terminals. Okay, that's the concept of a tie-grid inverter. It doesn't need any more battery for us to get alternating current from it. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.